All right, thank you. Yeah, my talk today is called Snap Back to Reality. Here comes gravity. And one of the reasons is because we all like these new technologies. We like the advances of VR, AR, 3D simulations. But then when we work in industries like automotive, architecture, and others, gravity hits us, and then we see the real problems. And I will go a bit through the problems and the solutions that we had for in automotive. So I'm Timmy Ghiurau. I'm an innovation leader at Volvo Cars. I have a background in music fashion. Then I worked with Unity, some startup with eye tracking that was sold to Facebook. Then I ended up at Volvo Cars, where I am leading simulation, AR, VR through the whole chain. And I'm a mix of creative and a nerd, and I think the intersection of creative thinking and critical thinking is where innovation is at the maximum point. And for me, when I joined automotive, which is one of the most traditional industries, I faced that I had to be in a box and to work with people in boxes. And that's all right, because sometimes we need a box to be able to think outside the box. And I had to learn what I'm dealing with, what are the problems, and how can I use my background in real-time 3D, AR, and VR that I was pioneering since the beginning, solve problems in the automotive industry. We as an industry, we are changing. We are moving into mobility ecosystem and to digital services. So everything from AD and safety that has been our core and DNA for since we were formed, to transitioning into mobility hubs and collaborating with the city planning and governments and how to yeah, offer freedom to move. And then also looking into digital services that can help us having impact on the world market. And Volvo vision is freedom to move in a safe, sustainable, and personal way. And we are looking into a future like this where we will have a lot of time since we won't be driving anymore and we will become passengers. And then we need to have a shift. So we need to change the way we've been constructing cars and designing and producing cars. Uh, Here is an example of some tests and simulation that we're doing to understand the user behavior. So we are running a lot of these tests on test tracks or in safe controlled environments to understand what is the future we are heading to. And with virtual experiences, we are trying to cover everything from product design to marketing to the whole R&D process, where we go from complete vehicle interaction, simulating software, simulating autonomous drive to HMI. And I know this focus is on training and manufacturing, but I will cover a bit some of the others and show how we learned that to aid the manufacturing sector as well. As I said, here are some examples on how we're using real-time 3D and AR VR to visualize cars from early blueprints. And we've been really early in this space, like since the 80s, with cave systems and VR systems. But then slowly we tried, I understood when I joined that everything was in silos and people were not communicating. Even if they used the same tools through the uh, life cycle, they didn't share knowledge that efficiently. And that was a problem that I understand that I have to solve. And we made a tool where we integrate like the car model with the real behavior of the car before we build it, so we can do user research, we can train people how functions are working, and also understand the whole process. And I think this is a key to understand what our product is before we go into manufacturing, and sharing that knowledge through the whole process from early design to development. So we teach designers to collaborate with engineers as early as possible and being able to have influence on the result, to HMI and UX research, how do we interact with the new systems in the car. And to do that, we are a really human-centric company. We're trying to understand the user, define and ideate solutions, prototype, test, and implement, and then we're going into the manufacturing. We started to collaborate a lot with Vario. Maybe a lot of you have seen this. We were the first ones to be able to drive with a headset on the road, and we were able to swipe between car models and being able to evaluate with eye tracking and biosensing with users, but also engineers and designers to take faster decisions. So we are driving the cars on the road before we build them, before we build it, the test prototypes. And here is an example where we can test and simulate and use this in another type of training where we train our researchers and designers how to understand different scenarios that would be too dangerous to test in real life. And here is an example where we're driving with the VRARA headset. Everything is real, the car is real, but the moose is virtual. And like both how the car reacts. And I got this question a few months ago from a friend that asked me, what can I see clearly today that I didn't see 3 months ago, or maybe even 6 months ago? And this is in the context of COVID. What I've learned, I've been to VR days a month ago, and I learned there from some presenters and friends that, for instance, in Germany, only 25% of the people were able to work from home. And how to assist the rest of the organization, not necessarily the white collar people, but everyone that works. And in automotive, we have such a complex product. We can't just, work in Excel sheets or CATIA. Sometimes we need to be there and touch the physical thing. And also, I learned that there is a really big trend in the urbanization where people are looking to moving away from the cities and look more into virtual workspaces, future of work where you can configure your work environment virtually. We start doing these presentations through Zoom, through Hopin, for instance, and I was quite skeptical in the beginning. It's like, will this ever work? Like having conferences in VR or online? And then people reminded me, like, weren't you the guy that preaching 7-8 years ago that we will all be in VR, we will collaborate around the cars and architecture, we will connect globally and have access to the latest tools and being able to speak the same language? Because I think when we are using the same tool, we are able to share knowledge in a more unified way. And we see a progress over the years that we're moving from PCs, mobile phones to XR wearables and personal robotics. Like our phones are not getting any bigger, thinner. And the reason companies like Apple are adding more cameras and LiDAR, it's not for better pictures. We all know that we're moving in the AR area, and there's been a lot of rumors in that space. And that's the reason I joined automotive. I knew years ago that we will wear wearables, we will be filled with sensors, they'll be have rich environments around us. And I was thinking, what's the best industry to learn this from? And it was automotive, because they were pushing for progress in AD, where they're using these sensors like LiDAR cameras, things that we see that are integrated in phones and VR headsets today. Like yesterday, Vario announced the most advanced headset that has LiDAR sensor and human eye resolution and cameras. And I had to learn how to use these technologies in the car to understand how this will be used by the users. So a lot of unknowns after COVID, and we had to define and capture the unknowns and understand how we can use this in manufacturing and training, and how can we train engineers and people in the factory to use these technologies. Like, as I said, learning from self-driving cars with LiDAR on how to use it with iPads, scanning components and adding job tasks on it. And we see concepts like this where this will be our future desk. where you don't need to buy screens anymore, you don't need to have expensive computers, where everything will be tangible. And we see, what if we can modernize um, the training and simulation as well? And we're collaborating with Tesla suits, and we are having gloves and the suit where this is taking the training to the next session. And I'll show you some videos. We used it a lot in safety simulations and ergonomics, but in training, where we're looking at the ergonomics in the factory, we had this project with Microsoft where we were 2014 got like 50 HoloLenses and created these simulation rooms where we could visualize cat parts, and people learned how to assemble them, and had these immersive tools to check their jobs. And also we took a lot of people through that training, and we got significant um, cost saving and improving a lot the efficiency. But efficiency here and there, of course, we can improve it, but it really matters if we have an integrated pipeline. We all need a CAD model, a 3D model of the car. We all need some functions and environment. It's just the fidelity that differs, and how many behaviors and functions we need for each item. That's why we made this automated pipeline from design, R&D, manufacturing, then a consumer-facing application. So we are able to collaborate in the company. Another thing, like how we do collaborative creative action around these technologies, because VR has been a promise for a while. And here is where we started to collaborate with Vario, and I can show you how we're using the technologies to do design reviews and look at this complex product remotely. So we started this collaboration. We see that we can build a car in front of us. The reflection matches the real world reflection, and also people can join from different locations. Um, we can look at like really intense details that was not possible before with consumer headsets, and Vario's human eye resolution was the only one that had accurate material colors and all this uh, resolution, where we can really use it for research and validation. And especially in interior and exterior, and when we put all the parts together, it's important that you have human eye resolution and really fast eye tracking that helps us understand more in perceived quality, in simulating like fluid dynamics, like wiper performance, being able to see your own hands, which really adds to the immersion, and just being able to jump from reality to complete virtual reality and test it in under different lighting conditions. Then we're looking on how to redefine the workspace, where again with Vario, we're thinking, why working with two screens in training, in uh, car design, in VRAD, in CATIA, when we can actually be completely in 3D, be immersed, and have more options on how to collaborate. And here I talked for many years with Timony West from Unity on what if, instead of working on Unity on 2D screen and taking the headset off and on, you could actually jump in Unity and be there and work on the model and see different components. This is an example, for instance, from airspace, but we're using the same concept. And then we were thinking, well, we have offices and factories all over the world, like in US, in California, in Charleston, in Belgium, in Sweden, in China. How do we connect with all of our designers, engineers, and people from manufacturing, and being able to look at the product together, bring specs, bring data in, like measurement of the car and details about ergonomics, and really collaborate together, being able to leave notes and just follow up later. So we're trying to modernize our tools, and we see a great adoption in the company. And as I said, then we take it to the next step where we try to drive with it and test different yeah, parts like roominess, visibility, ergonomics, perceived quality, illumination. So we can do all those tests early on in VR. And we had a PR event 2 weeks ago where we showed how we use all this technology in um, Unity with Vario and Tesla Suit to make safer cars. Like we have as testimonies of saving 1 million lives. And here we show what can we do with adopting this modern technology to save 1 more million lives, and how do we train our engineers, and how do we highlight the elements that need to be corrected in terms of the model itself, on the scenarios that are too dangerous to test. And here with the Tesla suit, we can train people to perform different actions. We can programmatically move their hands or make them do a different sequence. It has motion capture, biosensing, so we can see the users and our engineers and designers, like their emotion level and stress level, to see if performing a certain task makes you more stressed. And we were driving. This is shot directly through the headset, no CGI or anything. We had to remove the airbag in case of emergency. I know it sounds counterintuitive, but you don't want the airbag to blow in your face while wearing a headset. And of course, we had safety measures, like we had people with the steering wheel in the back if something happened, and we could brake automatically. And here we can see we overlaid the new model, and we see how it overlays on the real car. Um, we're driving on the test track. We're performing different tests in the same time, and we can see how we tested, like for instance, how a moose or another car would be appear in the front of the car. And here the car emergency system and ADAS system stopped the car, and with eye tracking we saw that the user was aware of that as well, because mainly that's the problem that appears. And here with Tesla suit we had motion capture, and we could identify the points where, for instance, the seat belt gets pretension, airbag deployment, and you see the dot for the eye tracking, where we try to see the handover procedure. If the car sensors acknowledge the scenario in front, also if the users is aware of that, because we wanted to test like the trust between the car and the human senses, because that's when conflicts appear, and that's when accidents happen. So we do this a lot for training and simulation. And here we just see how we get back. We also do a lot of automation for code, where we try to make the HMI, but not only that, also in the factory some process and for robots, where we can uh, make systems and HMIs that are really relevant for people on the line, for people that are working with the car during the design, but also the human machine interaction system that we put in the head-up displays or the screens. So we're trying to use the same pipeline to push for this. And of course, we have to stay ahead of the curve. The world is changing, and we need to adapt. And we always push the technology boundaries, so uh, we learn what's out there, and being able to create safer cars and offer the freedom to move in a personal, safe, and sustainable way. Thank you. Any questions if we have time? Yeah, we started to work with Vario years ago. I heard about them because I was interested to invest myself, but then I approached Volvo investment fund, so I invested in VRARA, and we saw their technology, I think 2016 or 17, really rough early prototypes, but we never seen anything like that. And when we tried it, we asked them, can we drive with it? And they said, what do you mean? Yeah, is the latency low enough? Because we see the resolution, but how's the latency? And in a few weeks, they managed to do it single digit, that we can actually drive without any lag. And we did a lot of research and papers about it. We didn't have, I think the main issues were what tracking system to use in the car. We tried different methods, like what we use now, it's an ART system and for tracking. But in terms of latency, we did like a lot of tests. We wrote some papers for about motion sickness by wearing this. Somebody asked about Tesla suit. Yeah, we are starting to use it in training and simulation. Ergonomics, where we can record more natural poses for sitting positions, and also in for safety, where we can simulate the deploy of airbag, of course, like lower force, but we can still identify which muscles are activated. And of course, for VR, it gets more immersive when you can touch screens, touch the virtual car that doesn't exist, and it's really accurate. And a motion capture system is really, really well done. It's not, yeah, I think you can do it with gaming laptop or more extensive gaming computers. We're using like RTX 6000 or 2080 Ti for running this software. But we can run it on iPads and mobile phones, like depending on the use case. But our pipeline is kind of platform agnostic. We just pump up the details. Somebody asked about the XR3. The most exciting thing is that they increased everything almost by 40%. It's half price and it has LiDAR technology. And we've been experimenting with LiDAR with the iPads, and we have LiDAR from Luminar in our next cars for AD. And that just makes it to the next level. We experimented where, for instance, you just scan your room with LiDAR and you invite another person. So imagine that you can scan a part, or you're on the manufacturing line, and you can just scan with LiDAR where you are and invite another person through a meeting VR to join you there in the meeting, and being able to talk about the same component instead of needing to send like the CAD parts and so on. Yeah. Great. If there are no many other questions, I will end here. Oh, somebody asked for training. Well, really depends on the budget. I'm a bit biased on Vario because for our use cases we need super high resolution. But I would go with Index maybe. As I said, we have like 50 HoloLenses where we tried that, but honestly, I'm keeping a lot of them in boxes. I'm waiting for whatever Apple or Google is planning to launch, and we're trying to do some pilot tests with to scale up with the training and simulation in our factories. So our factory in Charleston in US can collaborate with a factory here in Sweden and train more people there. Yes, we published something on this conference, and that was a UX conference, Kai. There are some studies on perceived quality. You can reach out to me on LinkedIn and I can send you some links. We did collaborate a lot with Chalmers and Stanford for some of those studies. Okay, thank you so much, and feel free to contact me. Have a great day.